Good morning. Bill Fuentes here from Harford Technical High School. What we are going to do today is we're going to go ahead and try a hand at a welding video. First off, we have to go through some general information about the welding process and what you need to know as a welder. There's a couple things that I advocate, and I have books, and we'll see the books later, that all the information that you really need to know is in these welding books. You just need to open the book and find out where it is. Now, if you are a good person that retains educationally a lot of information, you might have some of that up in your head and you could go ahead and recall it. But always remember, if you don't remember, go to the book. Okay? So first off that we're going to talk about is all welding that we do is considered fusion welding. And there are different types of processes in the fusion welding. The idea is that you're fusing two pieces of metal together by another piece of metal that is generating heat, and it connects the two pieces that you want to. So be it anywhere from shield metal arc welding to soldering. What you did with soldering is fusion welding. So when you soldered the diodes and you soldered all the lights, you were fusion welding at the time. If you use shield metal arc welding, you're going to fusion weld. If you use gas metal arc welding, you're going to fusion weld. So if you keep that in mind, you'll understand what we're talking about. We're going to talk first is the different types or processes of fusion welding that we are going to use. The first process, if you look to the left, down on the chart, you'll see that it's electric. This is electric processes. If you look to the right, that's a gas process. And further to the right, on the other side, opposite side, is what they call plasma process. Now, in the shop, we have each one of those processes. What I want to do right at this point is to center on the electrical processes. Now, there's old terms and new terms. I am older generation. Sometimes I slip and I use an old term. But you guys need to get used to what the terms are now. Because if you decide to go and look for a job and you give an old term, you might show that you're not really updated. Okay? Three of the processes that we want to talk about real quick, because these are the processes that we use for certification in the shop. There's a lot more electrical processes. What we want to look at is the modern terms that we have for some of the welding processes. The first one, which is GMAW, a lot of people call it GMA. The GMAW old term is MIG, right? The new term is gas metal arc welding. Gas metal arc welding and MIG is the same thing, but what we want to use when we do things here in the shop is gas metal arc welding. The second term shield metal arc welding, or SMAW, the old term is stick or arc, right? So the shield metal arc welding is the term we want to use, and the gas metal arc welding. But if something is mentioned MIG and stick, you'll know what that means. The third one that we use for certification is FCAW. FCAW is flux core arc welding. Flux core is a MIG process, but it has the flux, and we'll talk about the flux, inside the wire, right? So the flux core arc welding, basically, it's a wire with the flux being inside. So when you have that, you don't have to use supporting gases with it. Now, when we certify, because of AWS regulations, the flux core arc welding for certification, you need to have a gas supplement when you're using flux core arc welding, and that's why I mentioned it. Now, a normal wire will be solid metal. The second process that we want to talk about is gas processes. The gas process, if I could spell right, the gas processes that we use here is oxy-fuel welding. Now, what goes along inside the oxy-fuel welding is cutting, brazing, soldering. So this is called OFW or OF, which is oxy-fuel. That's your oxy-fuel welding. The plasma process has an electric arc to it, but it creates a plasma gas because of what they use in the cutting. So we don't have plasma arc welding, but we do have plasma arc cutting, which you will learn when we get into the shop on how to use the plasma arc cutter. That's another class, but I don't think I'm going to do something. I want to see how this turns out, this welding course or this welding class. If we could do that and go to the plasma arc cutter, that would be probably a good path to move. So we have plasma arc cutting in the plasma process. So what we are going to do is we are going to center our attentions today on the shield metal arc welding, or SMAW. This is one of the first things, except for my oxy-fuel, this is one of the first welding processes that you guys will use. Okay? Let's go ahead, we'll clean the board off, and I'll get you spun up on the shield metal arc welding. Now, when we look at the shield metal arc welding, the things that are very important before we start getting all our tools together is to know exactly what shield metal arc welding is. Okay, we're going to go ahead and take a look at some examples of some electrodes. When we look at these electrodes, they will do certain processes, and you as a welder need to know which rod to pick. Okay? So we're going to move over to this table. The main thing that I would like you to see when we look at these electrodes is, if you look at every single one of these electrodes, they're different sizes, but they also have a coating on the outside of the electrode. The coating is called flux. Now, if you can remember, when we were looking at the flux core arc welding, this coating is on the outside of this electrode, whereas on the flux core arc welding, it's on the inside of the wire. So the coating, if we take this and we break the coating off, it's a powder. And what that powder does, it creates an environment for the weld to be fusing, like in our fusion welding. So this creates an atmosphere that the rod can fuse. Okay? Now, if you take a look at this, this all looks the same, right? But it means a lot different. This rod here, which is a 308/16, that's for stainless steel. And the only way that you're going to know that is if you know the numbers on the rods and what they mean. The 308/16, 309/16, the 314, all those are stainless steel. Right? Now, you can use this on regular steel, but it's designed for stainless. This is all part of going into the book and knowing what rod to use for what process. All right. The next one that we want to look at, this is a real thin rod, and it's for, it kind of equates to the thinness of the metal. If you use the 6011 and the 6010, 6011 and 6010 are what they used to call farmer's rods. And farmer's rods are really good because it cuts through mud, grass, grease, and everything else to fuse. So these are very strong welds if you're using it out in the environment, right, or in a outside situation. So the 6011 has flux on it, the 6010 has flux on it, just like all the other rods. Now if we go over here, so this is a steel rod. I'm sorry to walk in front of the thing. This is a steel. This is steel. Steel. So all these rods right here are done with steel properties, metal, steel metal. So you have a 6013, which we consider a cover rod. So these do the root pass or the beginning of your weld. These cover them up. Now, a lot of times when somebody's doing fabrication, what they do is they weld and then they grind down the surface. It's still fused, the weld is still fused. You don't have to have that hump, right? You don't have to have that convex shape. The convex has the little hump. We'll talk about that in a minute. All right, so the 6013 is cover, 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 cover. And I will explain about the numbers and what they mean when we go to the board again. Okay, if you get anything out of this, each rod is covered with flux, and each rod has a different meaning.